Namusa has 30 sweets. She has 18 fruit, 7 aniseed and 5 mint. She's going to take at random 2 sweets, and we need to work out the probability that the 2 sweets will not be the same type. So let's just draw a little tree diagram of this. The first sweet could be fruit, aniseed or mint. The second sweet could be fruit, aniseed or mint, or fruit, aniseed, mint, fruit, aniseed, mint. So the first sweet, the probability of the first sweet being fruit will be 18 out of 30 because there are 18 fruit sweets and 30 in total. Aniseed will be 7 out of 30, mint will be 5 out of 30. Okay, now, given that the first sweet taken was fruit, the probability that the second sweet would be fruit would be 17 out of 29, because there is one less fruit sweet left now because we've already taken one of them out. So there's only 17 fruit left. There were 30 sweets in total, but we took one of the fruit ones out, so there's only 29 left now. Aniseed would be 7 out of 29 because there's still 7 aniseed left, and there's still 5 mint left, so that'd be 5 out of 29. Just do a quick check. These numbers here, 17 plus 7 plus 5, they add up to 29. So 29 out of 29 is 1, which is what we want. So we know those numbers there are correct. Or at least we think they are. Right, next, what about if we picked an aniseed sweet out first? That would mean there'd only be 6 aniseed left out of 29 in total. There would still be 18 fruit left out of 29. And there'd be 5 mint left. Again, just double check that, make sure it adds up to 29. If we took a mint out the first time, then that would mean there's only 4 mint left out of 29. And the fruit would stay at 18, and the aniseed would stay at 7. And again, do a quick check, make sure they add up to 29. Okay, so we want to know the probability that the 2 sweets will not be the same. So that's fruit and aniseed, fruit and mint, aniseed and fruit, aniseed and mint, mint and fruit, mint and aniseed. So we could multiply those together, get all of these probabilities and then add them all up. There is a much shorter way though. Instead, we could work out the probability of mint and mint, work out the probability of aniseed and aniseed, work out the probability of fruit and fruit, work out what they are, and then take them away from 1, and that will give us all of the ones that we actually want. So that's the method I'm going to use. So the probability of fruit and fruit is going to be 18 out of 30 times 17 out of 29, which gives 51 out of 145. Now we'll do aniseed and aniseed, so 7 out of 30 times 6 out of 29, which gives 7 out of 145. And then mint and mint, so that's 5 out of 30 times 4 out of 29, which gives 2 out of 87. If I now take each of those probabilities away from 1, that will tell me what the remaining ones will be. So 1 minus 51 out of 145, minus 7 out of 145, minus 2 out of 87. So let's do that. There we go. So we get 251 out of 435. That is the probability that the sweets will not be the same.